Thank you for inviting me to share my research with you today. My talk is titled Economic Incentives for Robotic Weed Control in Row Crop Agriculture. It is funded by the AI Farms Institute at the University of Illinois that is supported by the National Science Foundation and the US Department of Agriculture. We have a very diverse team of researchers working on this, including agricultural economists like myself, agricultural engineers, weed ecologists, and a student and a postdoc. Weed management in row crop agriculture is becoming increasingly challenging, particularly in the Midwest. Untargeted spraying of herbicides has resulted with the development of herbicide-tolerant crop varieties and low cost of herbicides. And as you can see on the graph on the left, the effectiveness of pesticides in killing and preventing damages due to weeds and pests has been declining over time, leading to large losses in crops. There are few conventional options and emerging chemical pathways for addressing weeds and dealing with resistant weeds. And in particular, conventional options typically rely upon dealing with weeds pre-emergence or before the canopy has been closed, and they're unable to reach the weeds that are prevalent and grow during the growing season underneath the canopy. Additionally, high cost of labor has been another reason why there's been a lot of reliance on chemical and spraying of herbicides rather than on mechanical approaches to dealing with weeds. So conventional herbicides apply pesticides and herbicides before the canopy closes and in the beginning of the growing season. An advantage of these emerging robots is that they can drive underneath the canopy of the corn and soybeans and detect and mechanically remove weeds. These are much more, robots are efficient, can work long hours and reduce the need for, they're fairly autonomous. They do not cause soil compaction and can delay and avoid weed resistance. Now, the decision for farmers, that are looking at these weeding robots are several. It's more than just a single yes/no decision to adopt a robot. Farmers will need to decide on the number of robots to adopt, the timing of acquiring the robot to adopt immediately or wait till the later till the weed resistance problem has really grown or the cost of robots has declined, the level of autonomy of the robot to choose, since these robots are going to be dependent on labor for to varying degrees. The share of farm acres to treat with robots versus with herbicides, and whether or not to rent or to buy these robots. And in general, we know that the adoption process for emerging technologies is a dynamic and gradual process, and the various stages of learning that are affected by the farmer's own experience as well as information from networks and peers. Adoption decisions are also expected to vary across heterogeneous farmers and locations. And so it will be important to understand what are the drivers of adoption, what are the conditions under which adoption will occur, and what form adoption will take, and the timing of adoption. Whether or not farmers will adopt these robots, sequentially, whether they'll adopt them as a bundle, what features will be adopted. So there's a number of uncertainties that need to be studied and examined in order to understand the incentives and the timing for adoption of robots. We know that there are several factors that will influence adoption, including economic factors like the returns to land, implications for riskiness of returns, the farm characteristics and the farmer characteristics, what type of farmers are going to adopt, whether those are more forward-looking farmers as opposed to the myopic farmers who have a shorter run horizon, the performance of the technology, as well as the public policy incentives that are provided for adopting robots, because they can reduce the dependence on chemicals and reduce the negative impacts on the environment of using chemicals excessively. These adoption decisions also be influenced by the behavioral preferences of farmers, the extent to which they are motivated by environmental concerns, versus as well as the resistance to change, the willingness to accept new technologies, and so on. And then finally, the access to enabling environments, such as access to the broadband internet, and prior adoption of complementary technologies like computers can also make it easier and lower the learning costs of adopting robots. So the early insights from our research suggest that farmers are more likely to adopt if weed density is high and the level of resistance of weeds is high, um, as well as if the yield damages with herbicides are large because of resistant weeds, and if the price of output is high. So they're more likely to be adopted on crops that have a high value added component. But also farmers that are forward-looking and recognize that weed management strategies today can affect the extent and resistance of weeds in the future, and it is better to adopt early, are more likely to adopt. Particularly if capital costs and learning costs of robots are low, and if the cost of labor as an alternative management strategy and herbicides is high. Low uncertainty about cost and performance of robots can also incentivize early adoption, as well as policy support for reducing herbicides and for undertaking more sustainable weed management would be another mechanism for inducing adoption of these robots. Thank you, and I'll stop with that.